We are curious about how airplane engines can generate such a large thrust, capable of pushing an aircraft weighing hundreds of tons into the sky. Today let's take a look at how it works. The turbofan engine is the power core of modern commercial aircraft, and its basic structure is divided into 5 main parts: the fan, compressor, combustion chamber, turbine, and exhaust system. First, air is drawn in through the large fan blades, which rotate at high speed like a big windmill, pulling in a large volume of air. The incoming airflow is divided into 2 parts, the core airflow and the bypass airflow. The core airflow enters the engine's core, while the bypass airflow bypasses the core and is directly accelerated through the bypass duct to generate thrust. The air that enters the engine core then passes through the compressor. The compressor is divided into a low-pressure compressor and a high-pressure compressor. It consists of multiple rotating blades and fixed guide vanes. The air is compressed by each set of compressor discs gradually becoming denser. In the end, the air is compressed to extremely high pressure and temperature, reaching a very high energy state. Then, this high-pressure air enters the combustion chamber and mixes with injected fuel, which is precisely sprayed and ignited. The ignited fuel rapidly reacts with the air, producing high-temperature, high-pressure combustion gases that expand very quickly. These high-temperature, high-pressure gases propel backward at extremely high speed, driving the rear turbine to rotate. The turbine is also divided into a high-pressure turbine and a low-pressure turbine. The function of the turbine is to drive the compressor and fan through mechanical connection, providing continuous power for subsequent combustion and air compression. As the turbine rotates, the engine speed gradually increases, and the combustion gases push the turbine to accelerate continuously, causing the turbine to spin faster and faster. Eventually, the energy produced by the turbine can fully meet the operational needs of the engine, at which point the engine enters a self-sustaining state, no longer relying on external devices. The final exhaust gases are expelled at high speed through the exhaust nozzle, generating a large reverse thrust that propels the aircraft forward. Then there's another question: how is the engine initially started? We all know that a car is started by an additional electric motor, and similarly, an aircraft engine is started with the help of an auxiliary power unit that provides the necessary power. There is a small turbine engine on the aircraft engine that can generate a high-pressure airflow. It starts the engine's compressor and fan, allowing air to enter the engine from the fan, ultimately bringing the engine to a self-sustaining state, propelling the aircraft to soar through the blue sky.